Hello and welcome to SUSECON, and I'm excited to be able to have you today to go over solving cybersecurity problems. Now, I wanted to start by talking about really the smoking gun, the elephant in the room. When we look at exploits that occur, a Gartner report that came out not long ago stated that 99% of exploits which occurred on where the security issues, the vulnerabilities, the holes were known to the company already. 99% of exploits, the hole was already known, but the exploit still happened. This is a smoking gun, if I have ever seen one. We don't often get to find smoking guns in the wild that say clearly your problem is over here. But this opens up a very blatant and brazen perspective on where we are with actually solving security issues. Equifax, their breach is a classic example of this problem. They knew that Apache Struts needed to be patched, that it needed to be updated, but they didn't do it. When asked, one of their middle-level managers responded with, "The person who is supposed to do it just didn't get around to it in time." So when we dive down into it, we have a lot of visibility into our cybersecurity issues, but we have very little ability when it comes to the actual repair of those cybersecurity issues. And so I want to ask the question, what is it that we should demand from the cybersecurity industry? And my response is going to be, we should demand security. The cybersecurity industry is built largely around not securing systems, but on finding the faults. And they've done an excellent job of finding the faults in our systems. But how do we get security, real security, from cybersecurity products if they're so good at giving us visibility, but clearly not good at helping us patch the holes and the vulnerabilities that we deal with? So who am I and why should you listen to me? My name is Tom Hatch. I am a pioneer in the DevOps field. I created the Salt automation platform, and from a cybersecurity perspective, I am former U.S. intelligence community. I've spent a considerable amount of time not only automating but also securing some of the world's largest infrastructures. And so, as I mentioned, I created a piece of software called Salt. Now, when I created Salt, my motivation to create this automation framework, which is probably something you're very familiar with as SUSE users, big fans of SUSE. They've been fantastic in rolling out and supporting us at SaltStack. But when I created it, my goal was more around being able to do high-speed execution, the ability to communicate with large numbers of systems. And the whole DevOps movement and the configuration management pulled us in with its great gravity, despite the fact even then that Salt still has arguably the best configuration management platform. But I want to emphasize that Salt, its intent, the reason why it exists, isn't just configuration management. It's about visibility into an infrastructure. It's about being able to enact rapid and powerful change on that infrastructure. It's about being able to take insights and turn those insights directly into action. And so I want to talk a little bit about why the cybersecurity industry then is broken and how Salt is the tool that can help us solve these things. When we come back and we look at what's happened over the last 10 years, is that a chasm has emerged. We have produced a significant amount of automation, DevOps automation, new ways of deploying applications, new IoT, containerization, Kubernetes, FAS platforms, a whole host of new systems. And these systems need to be secured differently, but also these new systems mean that we can deploy more apps. Something very common, which I hear, is, hey, we used to have a team of 5 who would deploy and manage 5 applications. Now that team of 5, thanks to using tools like Salt, are able to manage 50 applications. And we expect that number to continue to grow, that team of 5 can do more and more and more. But as we do that, the management of the security of these systems has waned, because we're much more concerned about the app. How do we deploy the app? How do we manage the app? What do we need to do to make sure that that app is available and up? And so security isn't on the top of mind when we are building out all of these different layers of automation. Instead, security is more often than not, unfortunately, a bit of an afterthought. We work hard to deploy the app and create the app. And once it's up, we ask, so, are there any holes? So I want to go over how the security industry is structured. Because when we look at infrastructure management, we're very familiar with how the automation and the deployment of applications works. But let's go through how the security industry is structured. They start by defining security policies. These policies help companies rightfully define what their security stance should be, what their security structure should be, and what the expectation of their team and their customers should be around how they have secured their infrastructure. Once those policies are defined, we spend more money and there are more vendors who help us scan and ensure that we are living up to that policy, or more accurately, discovering in what ways we are out of compliance with that policy. What are the many myriad of security alerts that are out there that we need to know about, that we need to be very cognizant of? And so once we scan the environment, we end up with a mountain of security alerts. And that mountain seems to be growing for virtually everyone. That mountain of security alerts and security issues then needs to be analyzed. We have to analyze it and say, what are the most serious? What are the most severe security issues? This analyzation goes in and with modern tools uses significant amounts of artificial intelligence, uses a great deal of mathematics to determine exactly where our hotspots are. Now, at this point, we've spent a significant amount of money. Scanning and prioritizing means that we've probably engaged multiple vendors. The definition of policies means that we've spent a lot of time inside of our security teams, as well as with vendors and advisors, to define those policies. When we analyze our security alerts, that also generally goes into a number of security tools. And so at this point, many infrastructures are using anywhere from 3 to 5 to 10 to 30 different security tools to be able to create a mountain of security alerts, a sizable number of issues that need to be addressed, and then filtering through them. Where are the real hotspots? Where are the things that matter the most? And the pinnacle of all of this spend and all of this effort is that we remediate that issue. That word, remediate, is thrown around a lot in the cybersecurity industry. But as we pull back the covers on that word, remediate, what we find over and over again, even with platforms that claim a great deal with their power to remediate, we find over and over again the same thing under the covers. We create a help desk ticket. All of this effort and the resolution goes into a ticketing service, a system which is, sure, better than, but fundamentally largely unchanged since the 90s. And so we end up looking a little bit like this, waiting forever to solve a security issue that is incredibly severe and incredibly important, but it's just been thrown over the wall to the infrastructure operations and management teams. So how do we fix this problem? If we have a problem, we first need to understand what it is. Where did this thing come from? And then understand the people that are inside of this problem. When we understand the people and its origin, then we can understand where those issues really lie. And then finally, we have to be willing to rethink the problem. So many people, when it comes to approaching cybersecurity, have had a very difficult time rethinking the problem. And we run into this on a very regular basis. And it's not being stubborn. It's honestly so many times a lack of understanding. I can't tell you how often I talk to cybersecurity professionals who say, I thought that this problem was solved. I gave it to my operations team. Therefore, they will solve it. It's out of my hands, they say. And similarly, the operations team comes back and says, it's solved until we get hacked. And then it's not my problem. It's not my fault. That blame always goes back to the security team. But to overcome this, we have to be willing to rethink the problem. Rethinking the problem means that we have to admit that there are aspects of this that we need to look at from a new light, look at from a new angle, and consider with more information than we have in the past. And so SecOps in many ways is the answer. But the SecOps movement, as it has begun to evolve, is very focused around simply saying, well, we made it to infrastructure automation or the infrastructure team, and infrastructure operations is now able to use automation tools to deploy security fixes. And that's what we call SecOps. I'm going to argue that that isn't SecOps, nor does it fulfill the ideals that DevOps originally tried to propose when we go back so many years into the foundation of the DevOps movement. SecOps isn't about saying we have automation tools to solve security issues. The same way that DevOps isn't about saying we have automation to solve developer deployment tools. It's about bringing these teams together. It's about making sure that the developers understand the scope and impact of the deployment that they are creating with their software, and that the infrastructure operations team understands where that software is coming from and how they can integrate with that software to deploy the application seamlessly and smoothly. So how can we apply this to security in a real way, not just saying we're SecOps because we use automation tools? One of the other things that I want to mention is that we won't have some of the luxuries of the DevOps movement. The DevOps movement began around saying, well, we can build automation, and that automation is a bridge between operations and development. But that grew into very complex and new ways of developing and deploying software. The container movement, the function as a service and serverless movements, coupled with specialized cloud services that are presented, ended up giving us a situation where there was always a new tool, and the next year always came out with another tool, but also a situation where the continued creation of these new tools presented new problems, new ways of thinking, and new very fundamental approaches to having to deal with the problem set. But when it comes to security, we have to deal with all of the tools that are out there today. We have to deal with all of the deployments that are out there today. We're not going to be able to simply write off the entire situation by saying there's a new way to deploy applications. So let's dive into analyzing the problem. When we begin to analyze the problem, we can ask ourselves, who are the people that are involved? So let's start with security. What is the job of the security team? The security team's job is to find those issues. Their job is to define and find. And so that's what they do. They scan networks. They work with auditors. They go through vulnerability scanning. And then they're there to run forensics when an attack actually occurs. So that's their motivation. Their motivation, they wake up in the morning and say, today I need to find security holes. Frankly, if they can't find security holes, we begin to question, why are we paying these people if they aren't finding security holes? Which in and of itself presents a problem and a motivation problem. We should wake up and think about our security people in the same way that we think about our operations people. We need to come to our security people and say, not just you need to find holes, but why have you allowed this hole to stay open as long as it has? What is the age of the hole? And how does the age of that hole and our knowledge about that hole reflect our ability to secure our infrastructure? But again, their focus is finding the issues, defining the profiles, and narrowing down on those issues. And so let's look at security people's workflow. They gather that security data with the scanners. It looks very much so like what we just talked about when it comes to the cybersecurity industry as a whole, because the cybersecurity industry has built itself around this workflow. They gather the security data. They find the security alerts. They prioritize the issues, and then the crowning achievement is that they file a bug report in ServiceNow or Jira, and then check in with the IT department and say, why haven't you fixed any of these yet? Or we said this one's a really big deal, but it's still glaring, open, and a problem. Well, once that gets over to the operations people, we need to step back and say, what's their workflow? What do they think when they get up in the morning? The objective of operations people when they get up in the morning is to deploy and maintain the applications that are being presented to the world by the company. If those applications go down, they are in deep trouble. Nobody notices operations really until those applications go down, until there is a real and very legitimate problem. And so who are operations people? They wake up in the morning and they care about deploying applications. They care about maintaining systems. They care about uptime. And when I say uptime, in the old days, and for a lot of organizations, still today I should say, uptime means that those applications are presented to the world 99.999% of the time. They only have a few minutes, a year, at which those things can be down. But I say that, and we've seen many operations, many data centers, and many infrastructures where the expectation certainly isn't that it's up 99.999% of the time, or as we like to say, 5 nines. But it's that the latency never drops below a certain level. It's very simple to say, sure, up and down, but if we come back and say our average latency cannot drop below, say, 80 milliseconds, or in some cases even a few milliseconds, this is what drives these people. So what does their workflow look like when they receive one of these tickets? Operations people, their workflow is that they receive the security ticket and they filter it again. They have to filter it again. That security ticket came from a security tool. It was found from the outside. It was discovered in such a way that they don't necessarily even know where to look. And so they filter out the tickets not only based on severity, but they also filter out those tickets based on whether or not they know where the problem is, whether or not they are going to have the bandwidth to solve that problem. And security issues that have been out for a while, they usually come back and think, well, these security issues have been out for a while and I don't think we've been hacked yet. I don't need to stay up all night taking care of this. Now, don't get me wrong. Operations people, when they receive a security ticket, that they understand the severity is high, it's on an exposed system, and they know where it is, they will go and fix it on a fairly regular basis. But they end up filtering out many other very critical issues. And so not only have we gone through all this work from a security perspective to define the most critical issues, but now they're getting filtered on the other end yet again. Then they build automation to repair the issue. They don't go out and touch individual servers. I mean, there are a few infrastructures still like that today, but it's very rare. They build the automation to repair that issue. This is what we refer to as SecOps today, is building that automation. And so once they build the automation, they have to execute the automation. The execution of that automation is a very careful thing because remember, they can't allow that system to go down. That system has to stay up. And these infrastructures and these applications are far more complicated than they were only a few years ago. The days of a simple lamp stack where you say, yeah, I updated the database and everything's still fine, those days aren't really here anymore. There are intricacies inside of their applications, many system packages and system software components, myriads of open source software that needs to be dived into and scanned. And so when they execute that automation, it has to be in a test environment. Then so many times they create a canary environment to say, okay, I'm going to update this on a few pieces of the infrastructure that are in production and then roll it out to the rest, only when it's validated that those systems are properly fixed as well. And then 10 to 30% of the time, they get notified that the fix was incomplete. When they roll out that fix, the operations team at this point is very much removed from most security teams. They can't go to the security team and say, can you scan that again? Can you validate this? They come back, close the ticket, and say, we're done. Not having access to the same tools that were used to scan the system can in and of itself cause significant problems. How do you know that you're done if you don't have the ability to actually validate your work? And so real SecOps delivers. Real SecOps is the idea of combining these workflows. It's about delivering rapid results and real system level remediation, not remediation through saying my platform can solve 5% of the issues and otherwise I open up a help desk ticket, which is what cybersecurity remediation tools do. Real remediation is about integrating the fix with the find so that security and operations can come together and move forward on a collaborative tool. And so what would a real SecOps workflow look like? We still gather security information and define policies, but that information is fed directly into the automation and management toolset. That toolset then is able to directly execute automation that it comes with to solve over 95% of the issues. That automation is written to be flexible. It's written to allow the operations team to have a start. But so already what's happened is that when we find an issue, we've tied it exactly to its source. Over here, you have a misconfiguration that needs to be fixed. Therefore, here's a fix for that issue. It lowers the filtering problem that operations has to go through dramatically. But it also means that it's very easy to modify that automation to fit the nuances of your infrastructure. And since it's already tied to an automation tool, you're able to execute the automation in line. That full story can come together. And then instead of getting notified that the fix was incomplete, the security tool can validate the fixes for both teams. The operations team is using the same tool to fix that they're using to find. And in doing so, what happens is that they have a strong assurance right away that their fix is valid. Their fix is real. They are actually finished and don't need to fix this again in a few more months. So, the how is that we get the same people using the same tool. We are able to have systems management tools that are able to run the security scans. It's not enough to just have systems management tools absorb information from the security scanners. This is important. They still need to do this. But they also need to be able to scan the systems which they manage. And then we create a multi-team shared pane of glass. This means that the security teams and the operations teams have the same place, the same ground to work with. This is how you bring people together. You don't bring people together with philosophy. You don't bring people together with pretty words. You bring people together by having them fight on the same battlefield together, giving them the same objectives, the same tools, and the same goals. By sitting down with operations and security teams and saying, here is a platform, here is a view that is going to allow you to work together to solve these problems, is what creates real synergy inside of an organization and subsequently creates real results. Finally, when we automate the large groups of things, even the little things, you can make most of those small security alerts disappear. Those small security alerts are more often than not the easiest and safest ones to be remediated. If the automation is there, then you can patch your system quickly. You can make sure that your configurations are secure quickly. And so the end result is that you have a secure system from top to bottom, not a team that knows that there's always another problem and that even if they solve the red hot problems, there are infinitely more hot problems just underneath the surface. So all of a sudden, your task isn't a task in futility, trying to close a million windows in a million holes into your infrastructure. Rather, your task is a task in ensuring that all of those holes stay closed and knowing as soon as they open and being able to immediately shut them. Finally, having those scans run continuously allows you to have clean threat data. When we integrate with the management tool, we're able to run those scans significantly faster than the collection of other tools and with significantly less impact on the infrastructure. And so that means that we can achieve a window of assurance. A window of assurance means that we have confidence that the entire infrastructure is secure within a few days. That as soon as a CVE comes out, as soon as a misconfiguration is introduced, it can be repaired very, very quickly. And I can't tell you how often I've talked to CISOs who come back and say, what I want is a window of assurance. And then they laugh and say, but I can't get it. We're here to deliver a window of assurance. Now, I'd like to thank you all not only for listening to my presentation, but also, of course, coming to SUSECON. Again, here at SaltStack, we're big fans of SUSE. They've done a fantastic job. They make a fantastic product. And again, I'd like to thank everyone, and until next time.